I'm Alexander, and today's video will be spindle speed and feed rate testing of different mills and materials. In this video, I will share my results, followed by the raw footage of the machining for your reference. Timestamps can be found in the description below to allow you to easily hop between the sections that you would like to see. Without further ado, let's make some chips. To preface this video, I have a 400 watt spindle, and if you have a more powerful spindle, you should be able to get more aggressive feeds and speeds, as the rigidity of this machine is better than the spindle. On to the results. So here we actually have 5 tests and then 2 anomalies. So our first anomaly was the first test that I was originally going to use. When changing the end mill, I did not reset the machine offsets correctly. So this is a good reminder to make sure you do that appropriately, because otherwise you'll end up with a rapid tool movement through your stock, which normally would break an end mill. But thankfully it managed to work out successfully. It ended up being an 8.5 millimeter depth of cut at 1,125 millimeters per minute, but I do not recommend using those things whatsoever. On attempt number 2, for the first test, we ended up with a 1 millimeter depth of cut at 200 millimeters per second. As you can probably guess, this was easily done, and it wasn't necessary. It was kind of babying the machine. So moving on to test number 2, it was a 5 millimeter depth of cut, also at 200 millimeters per minute, and this would definitely be a good standard speed to use for clearing out any major areas of your models. The third test was also at 200 millimeters per minute feed rate, but at a 2.5 millimeter depth of cut. This was not necessary as the finish is nearly identical to the 5 millimeter depth of cut, test number 2. So I do not think it's worth the extra time to make 2 passes over 1. Test number 4 was done with a 1 millimeter depth of cut at 400 millimeters per minute, and it definitely yielded a nice side finish as well as bottom finish, so I do think this is a good finishing pass speed. Moving on to test number 5, this was an adaptive clearing path. So this was a 5 millimeter depth of cut at 300 millimeters per second. It is as clean as the other tests earlier, so I think you should stick to normal pockets as they are more efficient tool paths over the adaptive clearing. And if you are to do an adaptive clearing path, to maybe even go with a faster feed rate. Seeing how this machine ripped through wood with ease, I decided to also move on and test some drilling. And so I ended up using a 1/8 inch drill bit and making this hole pattern in the wood. And this was actually done really quickly. This whole pattern was done in 3 minutes. And I think it was a very mesmerizing and cool process to watch. Within reason, I think this machine is completely capable of machining wood as you see fit. And I will show you some close-up photos before we get into the raw machining footage.